So when it comes to the internet traffic, for example, on managed devices, we would like to deploy our client connector. That will go on to Windows 10, 11. That will go on to Mac OS, iOS, Android, and Linux. We can bring that data directly to the service edge using that application. When I'm at home, that's going to be over the internet. From a branch, that may be some form of SD-WAN, maybe IPsec, GRE, still with the client on the endpoint so that we can drive identity, but just forcing that traffic to us in a way that's really secure for you. From the tablet, that may well be over 5G, 4G, bringing that again using our client connector. Don't care if it's Android or if it's iOS. And then from a third-party point of view, we'll come back to that based on private application. We'll talk first about the internet piece. So the first thing we want to do really is work out the identity management piece. So we're quite agnostic. We'll work with any of the SAML providers really. Azure AD is by far the most popular one I've worked with companies. And I find that they're either on Azure AD or they're still running on ADFS, which again we can work with, but we've all worked with ADFS on other technologies, and it's not fun to do that configuration. But it's it's there, it's documented, it's quite doable. First thing we want to do when the inbound connection comes is to validate who that individual is. So if you're using Azure AD, we also get all the conditional access pieces to validate they're on the right device in the right location, so on and so forth. And then we are able to do device posturing as well within the client connector. We're then going to look at what they can and can't access, at which point we're going to throw their traffic out to whether it be SaaS or the wider internet. And again, because we're sending all of the traffic through our cloud, we're then able to do granular SSL inspection at scale. So I did this with a customer today where we went through the testing parts of the POV on SSL inspection on, SSL inspection off. And it made absolutely no difference to his experience on downloading a 1 gig file with the SSL inspection on or off, and it made absolutely no difference to him accessing individual sites.
Yeah, try to do that with VPNs.
Oh, exactly. So because it's direct closest hop, if you like, closest service edge, we have 150 data centers worldwide through to the application. There are some regional nuances around things like China, where you got the Great Firewall. That's always fun. Some of those incur premium data center charges and things like that. But generally speaking, the easiest way to understand this would be request comes in. Who are you? Are you on the right device? What's the policy assigned on your access? Okay, now we can start doing the single scan multi-action piece and pass your data on to your request out to the internet, or block it, depending. The SSL inspection is really important because obviously without doing that, we're not able to apply things like DLP, file type controls, etc., because we don't have any visibility into the stream of data, so we're not able to see what's actually being passed. So there are instances you may need to bypass SSL, which is not an us problem, it's an everybody problem, and they're generally around things like certificate pinned applications. So we're using SSL pinning in Visual Studio, for example. It's hard coded in rather than being something that we can, for want of a better phrase, man in the middle. So that's the internet piece, quite straightforward. When we look at the private application piece, that is going to be data center, random cloud. Let's pick Azure because it's the first one on my list that I come to. And what we're going to do is we are going to push a lightweight VM called an app connector as close to the applications you want to provide access to as possible. And they're going to make an outbound connection to our cloud. Two things to note there. First off, there's not a need to have that interconnection here to come into a VPN concentrator and then go out to the cloud or vice versa. And because it's an outbound connection, we've just removed the attack surface your VPN solution poses. Nothing is listening at the internet, therefore nothing can be attacked. This is a very interesting one when you think about security operations and IT operations. I have a colleague who refers to them as star-crossed lovers, because anything that's good for security operations, generally speaking, is absolutely awful for an IT operations point of view, because it makes life more complicated. And anything that is good from an end user point of view, from an IT operations point of view, is bad for security. Those two things generally repel like the same poles of a magnet. In this instance, what we're doing actually is providing application access to a user rather than bringing a machine onto the network. So if I've got an application over here, it's running on 443, one down here that's running on, let's say, 22, what I can do is I make the request, that request comes in, who are you, where are you calling from, where do you want to go to, and as soon as that's been confirmed, we're then going to effectively join these together like an old-fashioned telephone exchange, at which point we can make the connection through to the individual application that we're allowed to access, not server, not network segment, individual port and protocol on individual destination server. So we're no longer joining that endpoint onto the network, reducing any risk, and we are limiting what they can see around your network and access, because we're going to use a synthetic IP to hijack the traffic, if you like, and then send it into our environment. So when you think about what that means from an IT operations point of view is I no longer need to worry about convoluted routing tables. I no longer need to worry about the VPN stack. I no longer need to worry about segregation between Azure, the data center, and any of the other cloud environments. So my life is infinitely simplified from a network operations point of view. And my environment is infinitely more secure because I'm no longer joining things into the network. I no longer have threat of lateral movement in the same way that I had before, where if I was on VPN or in a branch, I could basically see anywhere in the network. I now can only get to the bits I'm allowed to get to on the ports and protocols I'm allowed. I can't do NS lookup. I can't go sniffing around the environment. So it's very, suddenly those star-crossed lovers of security and IT operations can, get a room or whatever it is they want to do because they're no longer at each other's throats.
It's probably a dumb question, but I'll ask it anyway. The home user, say that the home user has some sort of a worm virus or something on their machine. When they go to make that internet connection, is it the policy that comes up that will kind of go, oh, alert, there's something there, and just block the access? How does that work?
So if the app connector the client connector is installed, we're going to create a DTLS tunnel between that laptop and our service edge. All the traffic's going to come through. Now, we've a number of other controls in here around our advanced cloud firewall. We have other pieces around the IPS and so on. So if there was something like that on the laptop, there's now a bit of defense in depth, because whatever your EDR solution is, the endpoint protection solution is now going to be potentially picking that up from an AV point of view, as well as us seeing things like command and control requests and being able to block those. And identify them and alert you about them. In that instance, that would be happening. If that was trying to find its way around the network, all it would be able to do is get to, for example, the web front end here it's allowed to. It wouldn't be able to see the rest of the items in that data center. Or if I had SSH access to something, you'd be able to get to here. But again, you would need to know that FQDN to go to and so on and so forth. So it's very different way of looking at it, whereas before they'd be able to just go chugging around the entire network. The other thing this is giving you is feeding back into the agility piece. Well, let's say I go and buy a new firm. So I've got a whole batch of new users. Right, so I just need to work out the identity provider for that. So I can just hook in that IDP, their identity provider, whatever that is, into my tenant, and they can continue consuming their existing identity. And I can then authenticate them against the applications, all of their internet traffic and so on. It's just going to be a question of pushing the agent to the endpoints. If they also have their own cloud environment, I only need to provide that virtual machine in here, and I can now provide access to all of their applications to my users. So all those items we were talking about around M&A with IP collisions, doesn't matter, because you're not joining the networks together. You don't need to worry about any of that. You don't need to worry about routing. You don't need to worry about the compliance managers arguing over who has the insecure network and what needs to change before they do that piece there. Creating new identity and everything else. Yes, you probably will do that. You will likely want to consolidate down your IDP and so on in due time, but you're in a position where at acquisition +1, you can provide application access bidirectionally between the employees of both companies. And obviously, if you decide tomorrow you want to spin up Oracle Cloud or something else because, I don't know, you decided to self-harm in a new way, you literally just spin up your new environment, spin up your app connector, and then throw that in. Because we are, okay, so in Azure, AWS, I think GCP, we're App Store or whatever it is, you can just turn us on. You've got OVA, Hyper-V, where you can download images to deploy. You can do a sudo yum install on the standard Linux build as well. So we are really agnostic. Like I said, I had this working on the free compute I got offered in Oracle Cloud, just as a thought exercise more than because it was a good idea. But enables you to consume IT in such an agile way. When we talk about the third-party access, what we're doing there is twofold. So there are, strangely enough, government entities that I've spoken with that will hand out laptops to their third parties for them to use to access their resources. Quite expensive, bit of overkill. They spend up to 3 months turned off, sat under a desk until they need to be used for that once a quarter piece of work. Yeah.
Yeah,
or,
we actually had that. We actually had that in the school system.
It's mental, isn't it? When you think about how much it costs in hardware that just sits there, and then the overhead of the compliance, because they get turned off for so long, they drop off the AD, they drop off the MDM, and so on. All of that stuff aside, is just really inefficient. The other thing that we find is that you will have instances like a certain vulnerability management company that I worked with once upon a time, where you've got intercompany VPN. So they have a VPN within their network to our network, where they can then access every single one of their vulnerability scanning devices. From there, they can jump to every single server in the estate globally. So you can see the risk there from a compromise point of view. The reality was that whilst that gave them access to SSH and a chunk of stuff on the back end, reality, I think, Chris, it would be safe to say that most of that traffic was over HTTPS, so through either API integration or through a web front end. You didn't need to have full access to the box.